All right, welcome everybody. My name is Kevin, and we're here for the gRPC Maintainer Talk. Going to talk a little bit about what's new in gRPC. So before we jump into the main content for the session, more technical stuff, I did want to share a little bit of the success stories that we've had with gRPC over the last year. What we're seeing right now is for Java and Apache Maven, we're having 1.7 million downloads every week. For Python, also really great numbers, 24 million weekly downloads, number 72 most downloaded package over the last month. And then finally for Node, NPM, 13 million weekly downloads. And so we just continue to grow. Want to thank all of you for your continued usage of gRPC. Another thing I wanted to share was sort of the chart of the growth of GitHub stars. We just continue growing and growing up and to the right across all our various languages of gRPC. And so this is really great to see, and hope that it continues. One of the feedbacks that we heard a few years ago at KubeCon was basically the documentation that we have was not up to the standards that people wanted to see, and that what they expected from open source projects and what they were seeing on other projects they were using. And so one of the things that we've done over the last 2 years is really double down on a bunch of our documentation efforts. Just this year, we added 4 new documentation sections, 39 new videos, and a bunch of new code examples. And the year before, it was a ton more. So we've really been, doubling down in that area and made a shift toward trying to make short, consumable YouTube videos for a lot of the features that we add to kind of give you an overview, get you started, and see that content. One of the other big things that we're doing in gRPC is adding support for Rust. This is another one of those areas where we did see a lot of requests coming from the community here at KubeCon and at other conferences. This was one of the most requested features. And so we wanted to share with you the roadmap of things that we plan to build throughout this year. And one of the things that we're hoping to do is at gRPC Conf, which is later in the year in August, we are hoping to release a preview release with a bunch of the features that you can see there. And so this will be sort of a pre-alpha preview, and hopefully with hands-on code labs at gRPC Conf. And then you can see the rest of the feature rollout to the right. If you are interested in Rust, we would love to hear from you. If you want to be part of the early feedback, let us know, review what we're doing. We are looking for folks who want to do that. So if you are a Rust developer or interested and would like to help us along, please fill out the link there for interest, and we'll be reaching out to share things with you. I mentioned the gRPC Conf. We run a big conference at the Google Cloud headquarters in Sunnyvale, and the date is August 26th, and we just opened the call for speakers a couple days ago. And so if you are a gRPC user and you want to come and talk about ways you're using gRPC in your application, or if you are one of the folks submitting code for the project, we would love to have you. Be part of the call for papers. If not, stay tuned. Looking forward to the announcement for, the ticket sales and such for the conference when we publish the schedule. So would love to have all of you there. It's a really, really great event. It's a nice place to come together and hear from both maintainers of the project as well as folks that are out there and users. One of the things that we've done recently is we wanted to put together a special sort of announcement list for really key announcements. Things like outages or security issues, security patches, things like that, where it's sort of a list that we really think everyone would like to hear about those messages. And so if you haven't seen this, the gRPC-IO-announce is where that's at. And we have another mailing list that's not mentioned here, just without the -announce at the end. And that's where you can post your questions and comments and sort of speak more socially. And so there's a whole lot of messages on there every day. And that announcement list is different than what we have here. You know, this is really just core key messages from the maintainers about releases and any kind of issues and things that you'd need to know. So if you haven't done so far, please take a chance to subscribe to the mailing list. One of the last things I wanted to let you know is talk about some of the efforts that we're doing around making a proposal for graduation for CNCF. So right now we're an incubating project and we would like to become a graduated project. And one of the things that we're doing is rewriting the governance for the gRPC project. You know, we started talking with CNCF about graduation around a year ago, and one of the feedbacks that we got was some really key changes around the steering committee and around other governance items that would really help make you know, the project governance significantly better. And so, you know, don't be surprised when you see those coming. It's really something that's really driven through, you know, working with the CNCF on how we can make this a better project for open source and for all of you. And so with that, I'm going to hand it over to Gina. And before she jumps on stage, we should all do a round of applause because Monday will be Gina's 10-year anniversary at Google. So pretty awesome.
All right, thank you everybody. My name is Gina and I'm one of the gRPC maintainer. So as you may know that over the past few years, we have been committed to making the cloud native adoption as easy as we can for you, so you can scale your services seamlessly. So Process gRPC Service Mesh streamlines the deployment process by eliminating like the manually operational overhead associated with maintaining and also like managing your sidecar process. So also Process gRPC comes with many features that allows you to bring the service mesh capabilities into your gRPC applications. gRPC supports various authentication and authorization mechanisms, including like OAuth, the JOT token. It can be also integrated with the load balancing systems to distribute the traffic across the multiple service instances. It also provides a reflection service that allows the clients to dynamically discover the methods and the messages supported by your server. And gRPC also comes with built-in retry and timeout mechanisms that can help you to improve the fault tolerance and reliability of your services. gRPC also allows the developers to intercept the request and the response. And last but not least, we support the plugins that you can use to expand the functionality that you need. So the Kubernetes Gateway API announced the gRPC route resource in GA. And it's supported in Google Cloud Platform and also other cloud providers. So this powerful feature allows you to easily define the sophisticated routing rules with their gRPC applications and enabling the precise control over the request and control of how the requests are directed across all of your backend services. With gRPC route, you can leverage criteria such as like the service methods, the headers, to match incoming requests and route them accordingly. This fine-grained control enables the advanced traffic management strategies like canary deployments, A/B testing, and the traffic splitting of your gRPC services. We are also expanding the observability support to OpenTelemetry. So it helps you to troubleshoot the problem and improve the reliability of your gRPC applications. So you can make better decisions about how to architect and also manage your systems. OpenTelemetry metrics are available in all the languages that gRPC supports. And you can get these metrics to help you to analyze the RPC latency, QPS, error rate, and also things like the payload sizes. So you can find the full list of the metrics that we support at the documentation that I have on the slides. OpenTelemetry tracing is also available on gRPC. So we would like to encourage all of you to give it a try and let us know if you have any feedback. We are also excited to share that stateful session affinity support is now available in gRPC C++. So it is a load balancing technique to ensure that all the requests from one particular client are routed to the same backend. This is particularly useful for applications that maintain a per-session state information, such as like the shopping cart or the user profiles. gRPC implements the stateful session affinity using cookies. So when the first request is sent out, the gRPC client will route to a server as a normal request based on your LB policies. And in this example, the request 1 happens to be go to the server 2. And the server 2 encodes its identity into a cookie and then populate that information in the set cookie response header within it. So you can see that the cookie attached to the responses 1 here, and the client will receive the set cookie header in the response and uses the cookie to define a session. So all the subsequent requests in the session needs to be populated with the same cookie. And the gRPC will route or ensure that all the following requests will be sent with that cookie will be sent into the same server. So here, the client wants to send another request in the same session as the request 1. So it populates the request 2 with the cookie returned in the response 1, and the gRPC will route the request to server 2 based on the cookie. So until the cookie expires or like the server 2 goes down, all the requests with the cookie will be routed to the server 2, and as a result, you are guaranteed to always have a warm cache of that session, significantly speed up your applications. So now you know like how the stateful session generally works with the gRPC, and let's take a look how you can configure it. So we have introduced a custom resource called GCP Session Affinity Policy. So in the YAML file, you will set the cookie TTL time in seconds, and the session cookie will be expired at the time that you provided here. So before it gets expired, the requests with the session cookie are guaranteed to be sent into the same backend. And then you can also set the target reference to specify which route or service that you want to enable stateful session affinity on. Another cool feature that's launched recently is dual stack backend support. gRPC clients currently support both IPv4 and IPv6. However, most of our language implementations didn't have support of like individual backends having both IPv4 and IPv6 addresses. So with this new launch, the resolver and the LB policy API will support multiple addresses per endpoint, and happy eyeballs will be used to minimize the time to determine the address. So we are happy to announce that dual stack backend support is available on gRPC across all the languages that we have, and you are welcome to give it a try and let us know if you have any feedback. So to further enhance the reliability and the resilience of your service, we also recently introduced another new feature, XDS fallback. So this capability addresses the critical needs of like continuous operationing by allowing you to configure and deploy a secondary control plan alongside with the primary one. So when your primary control plan is not available, It could be whether due to like the planned maintenance or unexpected network issues. Our system, gRPC, will automatically switch over to the secondary control plane. So this automatic failover mechanisms ensures you that your service will remain operational and accessible by your users without any interruption, and also minimizing the downtime and maintaining a consistent user experiences. All right, with that, I will hand it over to Richard to talk about our next feature.
All right, thank you, Gina. So, first thing I'm going to talk about is a bundle of features that have sort of been driving towards proxyless service mesh on Cloud Run, a serverless platform. So, service mesh operators generally don't run on just Kubernetes, whether they like it or not. Feature teams in their organization often run workloads on various serverless platforms as well, such as, for example, Google Cloud Run. Unfortunately, there historically hasn't been great interoperability between these two types of platforms for service mesh. For gRPC proxyless services in particular, we've seen good support for Cloud Run to Kubernetes. And in fact, Kelsey Hightower demoed exactly this when proxyless was first introduced back in 2020. But the other direction, Kubernetes to serverless, hasn't worked out nearly as well. So with Google Cloud Run in mind, we've designed and implemented a handful of features that make this a first-class experience. First, we've added XDS host rewriting that enables the use of vanity URLs in XDS targets, something very common on serverless platforms. Next, we've added JOT token-based authorization for outgoing service mesh mediated RPCs, and finally, MTLS auth based on SPIFFE identities. Putting all of these features together, the integration between serverless and proxyless services is now truly first class. And you can see these coming to Java and later other languages in the coming months. So next up is XDS global rate limiting, a really exciting new capability with gRPC proxyless, and this is the first time that we are talking publicly about it. So global rate limiting is great for situations where your servers may frequently be overwhelmed by requests. Most rate limiting solutions require some kind of proxy, whether it's a gateway ingress proxy or a server-side sidecar proxy. With XDS global rate limiting, gRPC servers natively implement this rate limiting functionality directly in the gRPC library in conjunction with a control plane. This feature leverages the existing XDS protocol for service mesh, as well as a new RLQS protocol designed specifically for aggregating load information from servers and asynchronously programming rate limiting policy from a globalized control plane. This means that you get the benefits of global rate limiting decision making and also the benefits of a completely decentralized data plane. So here's a bird's eye view of how this works. The XDS control plane sends configuration down to the gRPC server with instructions to connect to an RLQS server, a service dedicated to programming rate limiting decisions in gRPC servers. The server will then connect to that RLQS control plane. The gRPC server groups requests into buckets based on their metadata. And for each bucket, the gRPC server will periodically send usage reports to the RLQS control plane. So for each of these buckets, the RLQS control plane will send query per second limits down to the gRPC server, and that happens completely asynchronously. If the query per second rate exceeds the per bucket maximum at any time, the gRPC server will reject that request with a configurable status code. So putting this all together, you have a highly performant, globally aware system for managing high-volume systems. The protocols and gRPC library implementation described here are completely open source, and a first RLQS control plane implementation will be coming to GCP Cloud Service Mesh within the next few months. So moving off of service mesh, another change I'd like to talk about is protobuf editions. Think of protobuf editions as a versioning system for protobuf features. Instead of having separate syntaxes like proto2 and proto3 with fixed sets of rules, protobuf editions provide snapshots of protobuf features with customizable settings. This approach ensures forward compatibility, allowing code written in older editions to work with newer ones. By unifying features and enabling incremental updates, protobuf editions make it easier for developers to keep their code up to date and maintain flexibility in their projects. Protobuf Edition 2023 is the first edition, and it essentially combines the features of Proto 2 and Proto 3, and it's supported in many languages. There are a few code changes you'll need to make to adopt protobuf additions, and you can find more details at the public documentation in the link below. We're also working on a new CLI tool called ProtoTiller to help with migrating these files, messages, and fields to new values for each feature. In addition to all of this, the gRPC team is working on other improvements to how you develop using protocol buffers in the future. So I want to give one quick preview at the next edition of Protobuf 2024. You can expect a few great cross-language features like symbol visibility and style guide enforcement, as well as plenty of language-specific improvements. And that is it. There are tons of ways to engage with gRPC, the project, and gRPC, the community. We, of course, have our grpc.io website that Kevin mentioned earlier. We are continually revamping with improved documentation. We, of course, have our YouTube channel where we have tons of getting started guides growing every day. We have meetups both physically and virtually. You can always meet with a maintainer from the gRPC project just by going to that link. And of course, join the various mailing lists we have. So with that, I think we'll move on to questions.
Any questions?
Hello, I have a couple. So I think the gRPC docs said, like, if you're happy, just keep with Proto 3 and don't bother with additions. Do you recognize this statement, and is it still true?
I think it is basically true that if you're happy today with what you have with Proto 3, keep on living with Proto 3. So for the foreseeable future, yeah.
Thank you. And for the gRPC, your colleague was saying it does native OTel. Is this the stats handler stuff, or is this something new?
I think I missed the beginning of that question there. Can you say it again?
Yeah, you said the gRPC client now has like native OTel support. I think that was what you were saying. Is this, so we used to use an interceptor and then it moved to, I think, a stats handler. Is this a new something else as well now?
Yes, we have first-class OTel instrumentation. So I believe there have been third-party interceptors in the past. Now we're providing, very first-class OTel support from the gRPC project.
Okay, thank you.
Where are you, sir?
Hello, thanks for the talk. So I'm an OpenTelemetry Code maintainer, and I have a question regarding the OpenTelemetry instrumentation. Are there any willingness to basically work in the OpenTelemetry semantic conventions? Because currently I haven't seen any cooperation regarding the semantic conventions of RPC and gRPC between gRPC and OpenTelemetry. Or is there any plan to contribute back on to follow up? Because right now the the official OpenTelemetry Go contrib instrumentation, which is supported by OpenTelemetry, diverges completely for the one implemented by Google. And I think it makes a lot of confusion for the users which one they should use, basically.
Yeah, I think absolutely there's a willingness to collaborate. Let's talk in the hall about that.
Thank you.
Any other questions? All right, thank you very much.